kind of E. He's a special E. He's like an italicized English E, but he's actually a Greek letter. Does anyone know what letter he is? It's got a full name. It's epsilon in English, epsilon. He's a number just like pi. So tell me what you know about pi. Never ends. Part of a circle. Maybe you know a value of pi. 159. What do we call numbers that never repeat, never end? What number family is that? It's a whole number family. They never end, never repeat, never stop. Irrational. So E is just like pi. He's an irrational number, and he's approximately 2.718. 2.718. I had my money on you today, too. I'm going to put my money on you tomorrow. Am I really late? No, I just started 15 minutes early. Just so you would be late. His name is Euler's constant, which looks like it should be pronounced Euler, but he's Swiss and it's pronounced Euler. And there's kind of a joke that you're not a real mathematician until you know that it's Euler. He was a Swiss mathematician, 1800s. He invented the number. He invented a lot of other kind of cool stuff. But it's approximately 2.718. It goes on forever and ever and ever, just like pi does. So instead of writing with a log with a base of E, Euler came up with some new notation. And he decided he didn't like that. So he writes it as lnx. ln is the exact same thing as a log with a base of E. What does it mean? It's the natural log of x. Don't spoil it already. Now, if it's natural log, why wouldn't it be NL? That makes more sense. Natural NL log. Why is it LN? Well, what is the official language in Switzerland? It is not. Swedish would be Sweden, not Dutch, not Finnish, not Swiss. French is the official language in Switzerland. So what happens in French typically when you have a noun and an adjective? It's backwards, so that's why it comes from the French natural log, which is log naturel. So that's why it's ln. Really, really old people like me and maybe your professors, we used to pronounce this as ln. We kind of stopped that because there's another function that kind of sounds like that. But if you hear ln of x, that's what it means as ln. But we typically try to say lnx. Look at your calculator. You have an E button and you have an ln button. It is my favorite button on the calculator, the ln button. None of you have your own button, but I do, that's right. All it is, it's a natural log, so instead of having to do change of base with log base e, it gives you log base e. Now, if you want to calculate e, it's the second function, so let's calculate e to the 1 to prove what its value is. So go second function ln, then put in 1. And you should get, oh, I totally gave you 2.718 approximately. Because that's what E would be, right? Y to the EX and Y equals ln x are inverses of each other. So they're just exponential and logarithmic graphs. They just have special bases. I'm going to use two different colors. So if you're a color person, you might want to use two different ones as well. So let's start with e to the x. This is just like 2 to the x or 3 to the x or 5 to the x. We're going to graph it the same way. So we'll start with our little table of values in our head. If I put in 0, I've got e to the 0. What is e to the 0? 1. So we still get that y-intercept of 1. And then if we put in 1, what's e to the 1? 2.718. And let's just mark that point so we know later what it was. If we put in x squared, or x for 2, use your calculator, figure out what e squared is. $7.34 is the offer. E squared, 7.39. Okay, so we'll estimate 7.39. What's going to happen on the left side of the x-axis? So what do you know about all exponential graphs? Yeah, it approaches the asymptote and then goes upward. So it's just like a normal exponential. It's just got a funky base. I'm going to switch colors to draw the graph of ln x. Ln x is just the inverse of this guy, so how do we get the log graph if we have the exponential graph? Flip. So 0, 1 becomes 1, 2.718 becomes 2.7181. And then 7.392. And what do you know about the asymptote from the log graph? Flips. I am, just because I did both graphs on the same set of axes. Why do we need this funky base of e? Well, we'll see in a couple classes that there's lots of natural applications of natural log. So it comes up in biology, in chemistry, in physics. It's always got this really freaky number of 2.718. Why? We don't know yet. It's just kind of cool. A useful little fact, ln of e. And we're going to assume there's an imaginary coefficient or exponent of 1. So on your calculator, I want you to do ln of e to the 1. Why? Kind of. Simpler than that. Why? A little overthinking it there. So way back when we talked about logs, we talked about this. Yeah, it doesn't matter what number you put in here, as long as the base and the power are the same, what's it always equal to? Well, what does ln e stand for? So it's a short form for what? Log base e of e. What's log base e of e? It's equal to 1. All we're doing today is solving the equations. We'll do the applications next day. So take a look. The questions look similar to what we've done so far, except instead of a normal base like 2 or 5, what do you see in example 1? E. Instead of a normal log, what do you see in example 3? A natural log. So get your foldable, because we're going to be mixing today and going back and forth between log and exponential equations, and you need to have the steps in your head. Why are lumberjacks good dancers? Why are lumberjacks good dancers? They have natural logarithm. That was your joke for the day. So when you look at any equation from this unit, the first thing you need to decide, is this exponential or is it logarithmic? Because that's going to determine which steps you do. And as you've seen now, the steps are backwards. So you have to know in your head first which is which. How do you know if it's exponential? How do you know if it's logarithmic? How do you know? So exponential is variable is in the exponent. What does a logarithmic equation look like? It has a log somewhere in it. So this does not have a log, but has a variable in the exponent, so this is exponential. So open your exponential flap. Step number 1. So the only thing we're going to do different, instead of using a regular log with base 10, what do you think we're going to use here? We're going to use a natural log. It's the only thing's different on that whole list. Instead of a normal log, it's just a natural log. Okay, what was step 2? Expand using log laws. What do we do with the expanding? Exponent becomes coefficients. Perfect. I don't have any power or quotient law because I've just got the one thing on each side. I was just about to say I lost a half mark here. Tell me why. Have to put the brackets around it. Here's where log equations or natural log equations get way better than the normal is. What do you know about ln(e)? It's equal to 1. So I can simplify this into 2x minus 1 equals ln 5. You can only do that once you've dropped that exponent to be a coefficient. You cannot do it up here. Because what's going to happen up here is you're going to have 1 to the 2x minus 1, and your variable is still in the exponent. So you cannot make that equal to 1 until you've dropped the exponent. Write that down. Do not cancel until you've dropped the exponent. Okay, now what? So what's next on your steps? X's to one side, numbers to the other. This is just a straight up normal kind of equation. How do we get rid of minus 1? We plus 1. Can I make that ln 6? No, that's crazy talk. You can't add just a number with a natural log, whether it's natural or regular log. How do I get rid of 2? Can I simplify anything in this step? Did we ever simplify in this step with log equations? Never. This is a straight up calculator question. Only difference is you use your ln button. Make sure you're closing it off if you have the old operating system and you're bracketing the top. Offer of 1.305. Did you bracket the top? Did you close off the log? Found it? What the hell's a double error? Two on the bottom. Okay. So you know how when we did sine and cos, how they have to be less than 1 because of the unit circle? So we're doing sine law and cos law in the grade 11s, and a kid comes up to you and says, my calculator's broken. And they were trying to calculate this. I said, your calculator's not broken. Not so broken. Not so much. Well, error, right? Because sine and cos we know have to be less than 1. Yeah. So she's trying to take the inverse cos of 18,400 and something. Claiming her calculator is broken. Yeah, not so much. We're good. Everybody got that? Yeah. There's your first exponential equation with e. What's nice about them is they always end up being less work because of this little canceling right there. But can you cancel in this first step? No. When can you cancel? After you've... Again, if you did cancel, this is what you'd end up with. And how do you move that out of the exponent now? You can't. There's no way to do it. That's why you can't cancel till you've dropped it. Number 2. Exponential or logarithmic, and how do you know? How do you know? There's no ln's or logs, and variable in the... Okay, find a friend. I'll give you about 4 minutes to try this one. Okay, you tell me, step number 1. Oh, it's on freeze, thank you. Brackets where? Do I need brackets here? No. If you have them, great, but you don't need it because you're not subtracting like this when you're multiplying. And we cancel the ln3s. Why not? But there's one on the top, one on the bottom. What? It's so bad. 1 point, sorry? I just couldn't hear. I didn't hear it again. 2, 2? That's fine. Yeah, as long as all the x's are together and the numbers on the other side. Questions? Number 3. Exponential or logarithmic? How do you know? So close up your exponential flap, open up your logarithmic flap. Okay, step number 1. Logs to one side, numbers to the other, so the ln x is going to come over. Simplify, so this is where we squish down into one log. All the regular log rules still apply for natural logs, doesn't matter, it's just a different base. If we are subtracting, we... Marjorie, I see you nodding off there, wake up. Okay, next step. Convert to exponential. What's the base that we don't see? No. It's an e, not a 10, because it's a natural log. So e is going to go over. What happens to the 2? What happens to the ln? So I have an x plus 1 over x equals e squared. Not yet. So e squared is a number. We're happy. It's just like when we have pi on 2 or pi on 4. We just left it. We're happy with this. So I need to somehow solve for x. Don't overthink it. X is to one side. Numbers to the other. So this is going to come to the left and 1's going to go to the right. Sorry? Yeah. I'm going to move the whole thing together. So I'm going to leave the x that was already on the left, and I'm going to subtract an x e squared. So if I was just moving the x, I couldn't do it, but I'm just moving the whole term. This is just a coefficient, so it's just like 3x or 5x. E squared is a number. Ooh, yeah, we want to factor here, so we don't want to divide, but we want to factor. I know what you meant. Are these calculator questions? No, so we can't plug this into our calc, but we still have a step. What's our last step? We need to check it. So we can approximate this just from what we did with the log graph. I know it's -1 on the top, 1 minus something on the bottom, and we already did e squared from our log graph. 7 point-ish. Okay, so on the top we're going to have -1. On the bottom we're going to have -6.3-ish. So we can say this is approximately a sixth. Positive or negative? Positive, because there's negative, negative. So if I put in 1/6 here, are we okay? 1 plus a 6, is that okay? What about 1/6 here? Yep, so are we good to go? If you look at our e graph, where we went e squared was a point right on our graph. I would, otherwise you're going to have to do e times e longhand, and I would not want to do that. Yeah, you rarely get an e cubed in these because then you would have a cubic expression. So usually it's e squared. Questions so far? Number 4. Turn and talk. Decide if it's exponential or logarithmic. Okay, what is it? With a question mark at the end? Okay, what makes something exponential? How do you know something variable in the exponent? Does it have a variable in the exponent? Check. Okay, how do you know something is logarithmic? It's got a log somewhere in it. Does it have a log? Check. So which one is it? It's both. Now what? Okay, so I'd open both your flaps and decide step by step which one makes more sense here. Cannot compute. Okay, does it make sense to put logs on one side, numbers on the other? Well, that's already done, right? Logs are already on the left. So what's the first step for the other kind? Put the log on both sides. What's the purpose of doing that? Why do we log both sides? It's to drop that exponent down. Do we need to drop that exponent? Yes, so that's a natural step then, is to put logs on each side in order to get the exponent down. And I'm going to choose LNs because of the E. What can we do on the left? Okay, drop the exponent. ln E equals 1. Okay, now which second step makes sense? So what are the two step 2's? Expand, or all the logs onto one side? Which one seems to make more sense? Logs on, I can't expand. There's nothing I can do because this is a binomial behind the log. So let's put all the logs on one side and see what happens. Can't expand, can I simplify? Yes. Okay, so if I've got 2 logs, can I smush that down into 1 log? Yes. Okay. Okay, so convert to exponential. What's our other choice? What's step 3 on the other side? Is there any way to get that t by itself? No, so what's the natural next step? Convert to exponential. What's the base that we don't see, but we know he's there? There's Kerr's suggestion. Are we done? We got to check. Where do we need to check? Where might be the issue in this question? So it's this guy right here. Can't take log of a negative. So if we put in the 3, we're going to get 2 times 3 minus 1. Is that okay? There we go. So there's your first double, exponential and logarithmic. That was great. There's some satisfaction there. Go ahead and try number 5. We'll chat again in a few minutes. That way you can all see it and then you can debate. Grade 11, Unit 7, Rational Expressions. So tell me what you're doing there to get that. Yeah, and he's going to tell you what he did there.
Okay, I expanded x squared minus 1.
Not quite expanded, you factored. So this was rational expressions from grade 11, which was factor everything, cancel whatever you can. Don't make that face, it's okay. So can we factor the top or the bottom? What kind of factoring is it? Okay. Can we cancel? This is always the hard thing in this course. When do you cancel and when do you not? Why? Because you're canceling the whole binomial and you're multiplying those two binomials. I would only put that just to be able to test it, because now we just have to double check. So this is just in your head to know approximately what the value is. So if we square that and subtract 1, so is that going to, how do we know that's going to be a positive number? Yeah, 3 squared is 9, so it's bigger than 9. 9 minus 1. E plus 1 plus 1. 4.7. Conclusion? So your instinct was probably to multiply by the x plus 1. That's a normal instinct. And then what's the problem there? So even if you multiplied it out, once you got all the x's to one side, there's nothing you could do. So that's the hint. There's got to be another way to do it. And so this one just happens to be rational, simplify, and solve. Number 6, all by yourselves. No, this is a fun game. No, I like it. Here's a really, really, really common mistake. Somebody is going to do this. Yeah, because you get so wrapped up into dropping and everything else, you forget what you do to one side, have to do to the other. Now what? Cancel? Check it. Who had it? High five. Adding would definitely make it harder. What do you think so far?